Hi, chapter review, parts 1 and 2. This is the Dudley version. Find the factors for 28. Make ourselves a factor tree here. We got 1 and 28. 2 goes in there, let's see, 14 times. 3 doesn't go in. 4 goes in there 7 times. 8 doesn't go in there. Or 5 doesn't go in there. 6 doesn't go in there. We're back to 7. So here are all my factors. 1 and 28. 2, 4, 7, 14. Here we want the factor pair, so this is going to be slightly different. I'll do it like this. Could have 1 and 50. We could have, let's see, 2 and 25. 3 doesn't go in there, 4 doesn't go in there. We could have 5 and 10. So those are your factor pairs for that. Okay, prime factorization of 24. This is where we want to get it down to a string of primes. So let me just break 24 down. I could break that down into 8 times 3. And I could break 8 down into 4 times 2. 3 is already prime. 4 times 2 times 3. Break this down to 2 times 2. This 2 is already prime. And this 3 is already prime. So we actually have 2 to the third. 1, 2, 3 times 3. 248, a little more difficult. I don't know what this is actually, so we'll just do 2 times, let's see, 124. 2 is prime, but I can break this down into 2 times 62. And break 62 down into 2 times 31. So we could break this one down into 2 to the third times 31. Okay, the greatest common factor of 24 and 32. So I factored the smallest number because the greatest shall be the least. So I take 24. Got 1 and 24, 2 and 12. 3 and 8, 4 and 6. These are all my factors. That factor tree real quick. And I just start at the bottom and say, does 24 fit into 32? Too big. Does 8 fit into, does 12 fit into 32? Nope. Does 8 fit into 32? And yes, it does. That's the greatest common factor. The greatest shared factor is 8. It's the largest number that's a factor of both 24 and 32. Let's do another one here, 36, 72. So we choose the smaller number and we factor tree it. 1, 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Same thing. Does 36 go into 72? We start at the bottom and ask questions up. Yes, 36 does go into 72. The GCF is 36. All right, let's take a look at these last few targets here. Express fractions in simplest form or equivalent form. Just a quick tutorial on this. All this is saying is that 1/2 is the same thing as 4/8. You can take and divide 4/8 by 2. 4 divided by 2, you're going to get to 1. 8 divided by 2, you're going to get to 2. There's your 1/2. Or you can take and multiply 1/2 times 3 and multiply the top by 3 and the bottom by 3, and you're going to get 3/6. So equivalent fractions I think are easier than reducing them, but it's the same idea. It's whatever you do to the top in terms of multiplication division, you do to the bottom. So we got 35 42 here. You have to look for what numbers go into them. And if I don't know, I start with 2, and then I guess 3, and then I do 5, and then I just start guessing. In this case, 2, 3, and 5 don't work because 35, there's really not much that goes into it, but 5 does. So unfortunately, 5 doesn't go into 42. So then I started guessing. So 2, 3, 5, guess, and I look at it and I go, 7 goes into both of these. So let's try that. 35 divided by 7 is 5. 42 divided by 7 is 6. 5, 6. We're in simplest terms. When you get neighbor numbers, when there's only one that separates the top and the bottom, they're called neighbor numbers, you're done. If you get a 1 in the top and an 8 on the bottom, or a 1 in any number on the top, you're done. All right, so this one here is 5, 6. And then we have 18, 36. And most kids are going to start with 2 here. I would start with something bigger, because the bigger the number I start, the faster I get done. But let's just do 18 divided by 2. So 18 divided by 2 is 9. 36 divided by 2 is 18. Uh-oh, I'm starting to see something here. What if I divide those both by 9? 9 divided by 9 is 1. 18 divided by 9 is 2. That's the same as 1/2. Now, I could have divided by 18 right up front here, too. 1836. If I would have divided by 18 right away, I would have got 1/2. Either way, you've got to get it down into the simplest form. All right, so list the first 5 multiples of 17. Let's see if I can do this. 17, and then 34, and then it's 51, and then it's 68. And now I got to think about it. I think it's 85, but let me just try this. 68, 17, that's 5, and 2 is 85. Yep, 85. So those are the first 5 multiples of 17. First 5 multiples of 13, a little easier. 13, then 26, then 39, then 52, and then that would be 62, and then 65 will be the next multiple. So those multiples. All right, the least common multiple. So for the least common multiple, the least shall be the greatest. So I'm going to take the largest number, if you do it my way, and I skip count by it. 12, 24, 36, let's see, 48. And I usually do 4 or 5 multiples of it. We'll do 60, just make it 5. And then I just start asking, does 8 go into 12? No, that's not it. Does 8 go into 24? Yes, it does. The least common multiple, the smallest number that when skip counting, both numbers would land on, that's what the least common multiple is. So it's 24. So 16 and 25, and 5, again, I'll take the big number, 16, 32, 48, 64, 80. I did 5 multiples there. You know, I think about 5. 5 has to go into a number that ends in a 5 or a 0, right? There you go. That's the only one that ends in a 0. Of course, 5 goes in there. So, all right. Well, thanks for listening, and good luck on this test.